So the conductivity tester, it consists of a light bulb with a cord plugged into the normal AC outlet, but the circuit is broken. There are two leads coming down inside these plastic cylinders, and the leads come down to about right here. I have attached a wire to the two leads so that when we plug it in, you can get a sense of the full brightness of the bulb once it's plugged in and it has a complete circuit. So this is the brightest it gets with a fully connected circuit plugged into the AC outlet. So now I've unplugged it and I'm taking the leads out. And so now when I plug it in, the light bulb does not light up because the circuit is incomplete between these two leads. The circuit, in order for the light bulb to light up, the two leads have to be connected somehow by something that will conduct electricity, and that will light up the light bulb. Let's see how each one of our substances, what the result will be when we put the leads inside the water with the substance in it. This is pure distilled water. Okay, the first one is Ki. And then we wash off the leads so there's no contamination for the next substance. This is KCl. This is glucose. This is KNO3. This is paradichlorobenzene. This is acetic acid. This is benzoic acid. This is paraffin. And this is HCl, hydrochloric acid. Okay, now we're going to heat each substance to see how long it takes to melt. And in order to do that, we're going to use the hottest part of the Bunsen burner flame. At the bottom here is where we can let more oxygen in through by letting more air in. And different Bunsen burners have different ways of doing this. I can do this just by screwing it counterclockwise, and that allows more air in at the bottom. And as you can see, with more oxygen, that inner cone appears, and the inner cone is a much hotter flame than what we had before, and it's the tip of that inner cone where we have the highest temperature. So this is something that's very dangerous. You would never want to, like put your finger in there or anything like that. So be careful. Don't do this at home. In a crucible, 1 gram of each substance will be put in the crucible and then on the clay triangle, and we're going to time it the moment the flame is put under the crucible until the moment it begins to melt. Okay, the flame is under, so we're starting to time it, and we're going to wait until it melts, and that will be the end time. It's hard to tell, but the tip of the inner blue cone is about a centimeter below the bottom of the crucible. This is potassium iodide. Okay, and melting began. And now we have 1 gram of KCl. Flame on, time on. So the crackling you hear is the KCl not melting but gaining huge amounts of kinetic energy and popping out. So it has not yet melted. All right, it's been about 80 seconds and it's not melted. So we can assume that the KCl has been the same temperature as the flame and therefore is not getting any warmer with more time. And so therefore the melting point of KCl must be higher than the temperature of the flame. So there's no reason to keep on heating it. Okay, this is 1 gram of glucose, and we're going to put it in the clay triangle. As soon as I put the flame under, that's time 0. As soon as I take the flame away, when it starts to melt, that's the end time. Okay. This is KNO3. Putting the flame under now. And it's starting to melt. And you can see the liquid KNO3. This is paradichlorobenzene. Put the flame under, and it's melted. And you can see that it is a liquid. This is 1 gram of benzoic acid. Starting time now. And it's melted. And you can see that has become liquid. This is 1 gram of paraffin. Time 0. And it's melting. And you can see that much of the wax is liquid. The acetic acid we will not attempt to melt because at room temperature it is already a liquid. And the HCl, the hydrochloric acid, we will not attempt to melt because it is already a gas at room temperature.